This is how to measure the Zeta potential standard on the Nicomp using the ZPW software. To provide a little background on Zeta potential, this is the charge on the surface of the particle. So if this particle is negatively charged, it will move towards the positive pole. We place the sample in this cell, we apply an electric field, and the direction the particle moves in tells us was the particle positively or negatively charged. We also measure the speed the particle works at, and that tells us the magnitude of the charge. Was it 10 millivolts or 40 millivolts? During the installation, we're going to mix up a standard. This is the ZRS standard. We do that by placing 0.05 grams into 100 ml of water. We'll mix it for 3 minutes, measure it while applying 4 volts per centimeter in the applied electric field. We'll measure it 3 times for 5 minutes, and then we will compare the result we achieved, the average result, to the value we see here on the certificate of analysis. So we match up our final average result to the value we see here on the certificate that comes with the ZRS standard. So I bring a weigh dish over to a balance, and then I'm going to tare the weigh dish, add 0.05 grams of the ZRS powder, and it doesn't have to be super accurate. You'll see here I end up adding 0.055, and that will be good enough. And then I take that powder and dump that into a beaker with 100 ml of DI water, and we'll mix it for 3 minutes. Take one of the square plastic disposable cells, fill it about 3/4 full of the mixed ZRS standard. Then insert the electrodes. And it doesn't matter if there's a small amount of air at the very top, that should be okay. Orient it so the word plastic is facing the front. Attach the electrodes to the cell and place it into the system for measurement. Here is a top view of loading the Zeta potential cell. Connect the electrodes, put it down into the cell holder. Move this metal plate over to the left. Make sure that this slider is to the right, saying Zeta. Close the door. To switch over to Zeta potential measurements, come up here to particle sizing. Click on to Zeta potential. Yes, we want to move to Zeta potential measurements. And in the Zeta control menu, the only numbers we're really going to change when measuring the standard is right here, and it is already set to 4 volts per centimeter. Everything else would stay the same. This is the temperature we will control the cell at, the liquid viscosity for water. This is the angle we always collect Zeta potential at. We could do measurements in either frequency mode or phase analysis, PALS. We always use phase analysis. This is the dielectric constant of the liquid. This is set for water. The electrode we're using, the spacing between the electrodes is 0.4 centimeters. So this all looks fine. The next thing we do is under Zeta potential, click on Auto Print Save menu. And here we give the printout ID, ZRS standard or something like that. We'll do 3 measurements that are 300 seconds long. And under Browse, we again have to choose the folder where the data will go. And then for each measurement, we need to say ZRS 1.1, and we need to have point in a number such as 0.1 in the name. Save here, we'll say OK. And then we would click the G to start the measurement. So we click on G to start the measurement, click Yes to automatically adjust the light scattering intensity. There's some initialization steps, and I'm fast forwarding through this. It checks the reference beam, the reference scattering. There's a number down here for that. It does a few other things before it turns on the electric field, E field off, then it will turn on the electric field here. And we will start collecting data. We see here we're starting with a Zeta potential of -41 millivolts. At the end of 5 minutes, this appears. That is the average result for the first measurement. We click OK. And now this is the first of 3 measurements that we will average
take that average and compare it to the value on the certificate of analysis for the ZRS standard.
The palladium electrodes that were supplied with the system should last many years, but some samples may burn and/or discolor the electrodes. So when they turn black, you want to take the file that was provided with the original shipment and file the electrodes until they become shiny and silver again.
This is a nice new clean set of electrodes. See how they're very silver? When they turn black, you need to clean them with the file that's provided. When those turn black, you just file it down, remove the black color until it turns silver and shiny again.